like to share my screen and take the chance to share part of my journey and truly thank you, Neil, and Digital Futures team. So I will start sharing my screen. I hope you see my screen in full screen mode. Okay, I'm Sina Mostafavi, and I'm extremely thrilled and humbled to receive this year's Emerging Scholar Digital Futures Young Award. I'm joining you today from Delft, the city that I've been lived, worked, and studied for the past 10 years. Born and raised in Tehran, I'm from Iran and Netherlands. Moreover, in the past 4 years, I had a chance to work in the Science of Architecture at Bauhaus campus in Germany. In this presentation, I'm going through several projects that I've done in practice, research, and education. I would say that the boundaries between these three realms of research, practice, and education are rather blurred, but I will start with my journey in practice. I'm the founder of Setup Architecture Studio, as Philip mentioned, a studio which is concerned with combining and integrating or adapting digital fabrication and design technologies with geocultural specificities. As you can see in this project, Softstone, we are combining local craft of soft craftsmanship with digital design and fabrication. And then the result is a kind of transition from a very rigid body of stone to soft, as you can see in this facade. And it also continues to the landscape and creates this fluid feature in the design. So with this concerns with on digital design and fabrication on the one hand, and learning from crafts and local culture in design and construction on the other hand, I'm also very much interested on the way we can redefine the role of ornament and tectonics in building and construction. And at the same time, I'm very much interested on how we can look beyond the finished and commercial building products or materials by looking into sequences in construction and constraints and potentialities of different production setups, how we can learn from the history and how we can learn from other industries such as automotive, and what do they bring to architectural constructions. And at the same time, I'm very much interested on the way we materialize our buildings. What are the fundamental differences of subtractive approaches versus additive, and how these differences will redefine the past and present applicable models or future visionary models with which we can materialize architecture. In this context, materializing architecture, what is the role and impact of design media? And in an interdisciplinary setup, what role designers and architects can play to develop and advance tailor-made design media for more efficient products that may save lives and matters. So these concerns are somehow summarized in this book, Hybrid Intelligence in Architectural Robotic Materialization, which is also result of my PhD research, which is guided by great scholars and professors at TU Delft and also independent committee members outside of TU Delft. And the core topics which are discussed in this book are porosity, hybridity, and assembly, with which I kind of redefine the way we can materialize using robotic fabrication and how these differences may result in more efficient and effective building systems and material systems. So porosity is concerned with the way we can control the distribution of mass and void, and how we can translate the result of, for instance, in this case, optimization into something which is buildable, and what are the challenges of this translation, especially when it comes to robotic fabrication, and how we can innovate on the way we produce using robots. The second topic, hybridity, is concerned with multi-mode robotic production and multi-materiality, as you can see in this example, which is also a part of last year's Digital Futures workshop, in which I'm concerned with the way we compute multi-materiality, and the way by combining multiple techniques of fabrication, we can come up with new ways of building architectural components, and how we can combine different materials and how different material properties and behaviors can be mapped. For instance, in this example, a summary of the idea of multimode robotic production and multi-materiality is summarized in this chair, which is also exhibited in NAi and also presented in ETH Robotic 2018, in which we are combining multiple fabrication techniques. And the idea is to see how these different techniques inform the design and how we can benefit from each different techniques of fabrication, and what sort of hybrid intelligence and what sort of hybrid materiality we can achieve in different resolutions. Then the next thematic topic that I'm interested in is assembly, which is concerned with the way we can grow larger than the size of the production setup that we use, and how we can sort of incorporate a material intelligence or assembly intelligence in design and benefit from the multi-directionality, for instance, in this case, subtractive manufacturing, and how we can embed constraints and potentialities of different fabrication techniques while we are assembling. So that's why sequence in assembly is important, and how we can incorporate computational design intelligence combined with fabrication intelligence in an integrated design to production system. I would like to conclude my lecture with a series of projects that I had the chance to do in the Science of Architecture, which is a small school of architecture with full of energy. And I had really the true chance to spend 4 years of my teaching and research career in this institute. I'm sure Neil is also very much agreeing with me that it's a very small school, but with full of diversity and energy. For instance, in this project, in which we are collaborating with Audi car manufacturing company, we're combining two different disciplines of design, car design and architecture. And it is truly fascinating to see how within a short amount of time, we were able to design and produce a one-to-one mock-up concept car. Again, combining different disciplines, and as also Alexa kind of referred, having a kind of hands-on approach and learn by doing and making. Or in another project, which is also very much in tune with the theme of this year's Digital Futures event, material intelligence, we are looking on the way we can innovate in material design and also combine different techniques of fabrication and tune different techniques of fabrication according to different material properties and behaviors. Or in this case, how we can map human senses, in this case, for instance, listening to a music and then translate it immediately into an art piece. With this, I would like to conclude my lecture, and I'm really also happy that Digital Futures in the past year, especially last year where we were hit by pandemic, sort of filled the gap that we were facing, the gap of not having access to the studios and labs. And I'm also very much looking forward to see how next year's Digital Futures would sort of rebrand itself, considering all the challenges that we may face in the future. And with this, I would like to thank you, all the participants, Philip, Neil, and amazing Digital Futures teams, which saw my work, and I'm truly humbled and thrilled that I received this award. Thank you very much.